Today we are learning about linear measures. Unlike a line segment can be measured because it has two endpoints. The length of the segment is only as precise as the smallest unit of the measuring device you are using. So if you're using a ruler, it all depends on the smallest measurement on that ruler. So let's look at these two examples here. The length in metric units. So we're finding the length of CD using the ruler that is given on the screen. So A, we are measuring in centimeters. So each tick here is our unit of centimeters. We do not have any smaller measurement here, so we have to do it within centimeters. So C starts at R0, our first tick, and then we're measuring to D. D is in between 2 and 3. It's not quite to 3, but we're going to say it's about. Because it's as close as you can get to it, but we can't say it is 3. Now B. If you look at this ruler compared to our first ruler, the larger numbers, the ticks, all match up. So this is a centimeter ruler, but it also gives us smaller tick marks. These smaller tick marks is our millimeters. So we're going to be measuring in millimeters. So there are 10 little dashes in between each centimeter here. So there's 10 millimeters and 1 centimeter. So there's 10, then we get to 20, and then we get to 30. But the length of CD is not quite 30. It is in between. So if you were to draw a line straight down, it would hit at this tick mark right there. So 20, this tick mark is a little longer, so that's 25, 26, 27, 28. So we're at 28 millimeters. MM stands for millimeters. These two line segments are the same measurement, but it's just measuring in two different ways, getting a more precise measurement as 28 millimeters and saying about 3, I forgot to say the units, 3 centimeters here. Okay, now we're going to be looking at another example. So these rulers, we do not have any units on it. So we're just going to do it based on the numbers themselves. So how many tick marks do we have between our number of measures, 0 to 1? We have 4. So each tick mark is worth 1/4. So each one's worth 1/4. I guess I should put it here, starting off. So if we're at a 1 here, then we have a 1/4, and then we have 2/4. So this is 1 2/4. A 1 2/4, if we were to simplify that, that simplifies to 1 1/2. Now B, how many tick marks do we have between 0 and 1? 4, 8, 12, 16. So if you count all in between, there's 16 in between each unit here. So each one is going to be 1/16. I can't write that small up next to it, so just put 1/16 down here for each tick mark. So if we get to 1, then we have 1, 2, 3, 4, 5, 6, 7. B stops at the 8/16. So we have 1 and 8/16. And then 8/16 we can simplify, and 8/16 is again a half. So we have 1 1/2 for our measurement. And we are not given any units here, so we can't say centimeters, inches, or anything for these two problems here. Okay, now we're going to be finding a measurement when we are given a line segment. So here we need to find AC. So A to C, this full line segment here. So we're given this part here, AB, and then we're given BC. So we can take AB and add it to BC. And that will give us our measurement of our AC that we're trying to find. Sorry, you can probably hear Grayson in the background. He woke up from his nap. So AB is 3.3. And BC is 3.3. So if we add 3.3 plus 3.3, we are going to get 6.6, and our units is centimeters, and that is our length of AC. Okay, let's look at B. Now we need to find DE. So we need to find this segment right here. So we are given DF. And that's a full segment. So the full segment is going to be equal to DE, the first part of the segment, plus the second part of the segment, EF. So DE plus EF. So we're just going to substitute in what we have. So DF, we have the full segment here states it's 12 inches. So we have 12 equals. DE, we do not have. That's what we're trying to find. We're trying to find what DE is. And then EF here is 2 3/4. So, how do we get DE by itself? We have to solve for DE, so we have to get rid of the 2 3/4. So we're going to subtract it on both sides. Cancels out. So you're going to have DE equaling, and then you have to figure out what is 12 minus 2 3/4. Do not let the fraction scare you. 3/4, if you're thinking of quarters, is 75 cents. So what is 12 minus 2.75? And that is 9.25, which is 9 1/4. I didn't need a decimal there. You can always keep this in decimals. It's not that big of a deal if you convert it to decimals instead of fractions. And we're talking about inches. So 9 1/4 inches is our length of DE. Okay, now this problem here. We need to find Y and PQ. If P is between QR and PQ is 2Y, QR is 3Y plus 1, and PR equals 21. So this looks a little scary, which do not be afraid of this one. Let's start off with what it's giving us. P is between QR. So we have a line segment of QR, which P is in between it. So we need to draw that out. So we have a line segment of QR with P in between. Doesn't matter where you put P. This does not have to be precise of where P is located as long as P is in the middle of Q and R, somewhere on this line. Now, we just need to label what each thing is. It gives us PQ is 2Y. So, PQ is here to here, you would need to label it 2Y. QR, the full length, would be 3Y plus 1, and PR is 21, this length here. So, QP, 2Y, PR, 21, and then the full length of QR, we said, was 3Y plus 1. So we need to visually see this problem before we can begin it. So, our question is telling us to find Y, and then find PQ. So PQ, we need to find this length here. So let's first just start off with finding Y. So we know PQ plus PR is going to give us the full length. So let's start there. So 2Y plus 21 equals our full length of 3Y plus 1. We need to get Y by itself. So we have Y is on both sides, so we need to bring it over to one side. So we're going to move this Y over. So we're going to subtract 2Y to both sides. So we get 21 equaling 3Y minus 2Y just gives us a Y. And then we have to bring down our plus 1. Now we just need Y by itself. We have plus 1, so we have to get rid of that plus 1. We're going to subtract 1 to both sides. So Y equals 20. So that was the first part of the question. We had to solve what Y was. So we got Y equals 20. Now it's telling us to find PQ. PQ. So PQ is 2Y. So all we're going to do is substitute in our y that we found for the y here. So 2 times 20 gives us 40. So PQ equals 40. And then we just solved that problem. That one wasn't too bad. The main thing there was drawing out the picture. Okay, the last thing we're going to look at today is congruent segments. So congruent segments are simply lines that are equal in length. So here we have A, B, and C, D. They match up, so you can say AB is the same length as CD. So these are congruent. So we show congruent lines with little tick marks. So there's one tick mark and one tick mark. So AB is congruent to CD. And we write that by showing this statement here. Segment AB is congruent to segment CD. And this is our congruent symbol. It's the equal symbol with a little tilde above it. So a little squiggly one line. So this last example, we're going to determine which segments are congruent. So let's start with AB. Which segment is going to be congruent to AB here? This has 2 tick marks. Does any other line have 2 tick marks? Oh, CD does. So, and then do they look about the same length? They do. So AB is going to be congruent to CD. Is there any other segments that are congruent to each other here? We have EF here. Is EF congruent to anything? Has a 1 tick. And then HG down here has 1 tick. And these are about the same length if you were to take a ruler to them. So these 2 segments are going to be congruent to each other. So EF is congruent to segment HG. And there you go. And that is all today. Please reach out if you have any questions on linear measurements.